Good evening, ladies and gentlemen. Thank you for joining us this evening for the first ever Dr. Thomas A. Perry Faith and Science Lecture. I would like to welcome to the podium Dr. Perry, Chair of the CMU Board of Trustees and son of Dr. Thomas Perry.
Well, it's a real privilege for me to, in both my roles as a son and as a member of the Board of Trustees, to welcome everybody to tonight's inaugural Thomas A. Perry Faith and Science Lecture. Let me first acknowledge and express the University's appreciation for the generosity of Guard and Perry Faith. Thank you. Second, I would like to introduce members of Tom Perry's family who are here. I am one of his 4 children. My sister Laurie Massey, who is here and is a Central alum, and my youngest brother Chuck Perry is here from Dallas. Appreciate both of those making up. The third member of the sibling group, Tim, is in North Carolina and could not join us this evening. I'd also tell you that Chuck really wanted to be a Central alum, but he wasn't qualified for admissions. He had to go to the University of Missouri instead. We are also joined by 3 of his 8 grandchildren. Connie Ponder and her husband Mike. Raise your hand so they'll know where you are. They are both Central alums. Julie Massey and Dr. Jonathan Perry. Further, we have 2 great-grandchildren here. Matt Ponder and Christopher Link. And Christopher is working on how to be admitted to Central 4 years from now. We're looking forward to that. Christopher. And I am joined by my wife, Carolyn, who is also a fellow alum. I saw Tom Perry as a professor who engaged his students. The evening students gathered at our home were really special family moments for us. Laurie got to pass out napkins to those students who were in the house, and she reports that she really did it so she could check out those cute Alec boys. Shocked to be able to say that. The male members of the family spent our time slipping into the kitchen to see if there were any goodies left unattended that we could take full advantage of. But what we saw was a professor who truly loved his students. What is so special tonight is that a former student has found a way to pay tribute not only to a man but to the idea of intellectual curiosity. Tom Perry would be very proud of what Garth has accomplished with his life and what he is offering to the next generation of CMU students. Garth's legacy is that he is building a bigger house on the intellectual foundation he found at Central Methodist. Future CMU students will be able to explore this house of ideas and hopefully make their own additions. I know that the spirit of Tom Perry is enjoying this evening. And just so that you all recognize what you have at your places, there is a book of poetry that my father penned in his later years, and that is for you to enjoy and to appreciate his curiosity about things in his life. Garth and Terry, thank you very much for providing this opportunity. And with that, I invite Garth Lane to come to the podium.
Well, my name is Garth Lee, BA, Central, class of 1961. As a student, I took the minimum science and religion courses. I have been a maximum student of science and religion ever since. The word scientia, giving us the word science, means knowledge. The quest for knowledge gave science its name and mission. So too religion. Nelson's complete concordance of the Bible, which is this thick, cites the word know and its cognates many hundreds of times. To know God as creator and redeemer is a conditio sine qua non of religion. In Christianity, to know is a relational term, and the Bible suggests that God was motivated to create the universe in order to have relationships with her creatures. Relational knowledge is central to religion. I have long considered myself a minister scientist. I hyphenate minister and scientist, given that, after all, they are twin mysteries. Science and religion are akin to Siamese twins, sharing vital organs and tissues. Now, ordinarily, if either Siamese twin is seriously ill, the well-being, even the survival of its twin, is gravely imperiled. Medicine has been trying to separate Siamese twins. So too, for millennia, many culture bearers have been dualists. These dualist surgeons are trying to cut science and religion apart. They have divisively insisted that science and religion are opposing claims to reality. Only one can be true, and some say only one of these twins should survive. The 19th century featured influential dualist voices who authored books about the mortal wars between science and religion. And our speaker is from Cornell University, and Andrew Dixon White, well known to Cornell, wrote a lore on the history of the wars between science and religion, 2 fat volumes, and and yet here is a person we invite to be here tonight. Now, in my opinion, the darkest part of darkness is the concept of dualism. It has been my life's mission to pursue truth wherever it takes me. In my years with intercollegiate debate at Central, my coursework under Dr. Perry, Dr. Meredith Eller, and others launched that quest. Minister scientists have been committed to scientia. For knowledge is another conditio sine qua non for pursuit of truth about anything. Now, truth is one. Whoever discovers it. Truth is one because God is one. So I have sought truth wherever it takes me. And I have found many of the finest truth discoveries have been made by minister scientists. Roman Catholic Cardinal Nicolaus Copernicus was the first Latin advocate of experimental study, the first to use experiment in biology, even before Bacon invented allegedly invented the scientific method. Nicolaus Copernicus, he refuted the geocentric scientific view that had prevailed for 13 centuries. He dedicated his work to the Pope, a publication that propelled momentum toward a paradigm shift known as the Renaissance. This advent of modern science is appropriately called the Copernican Revolution. Johannes Kepler yearned to be a minister. His discoveries in mathematics and astronomy supported Copernicus' views. As a minister scientist, his Mysterium Cosmographicum, a very famous work, beheld what Rudolf Otto would later call Mysterium Tremendum. Sir Robert Boyle was a renowned Anglican who authored several important theological works. He is heralded as the first modern chemist. He pioneered the scientific method, along with some I've already mentioned. In 1663, he co-founded the Royal Society of London for Improving Natural Knowledge. That's the oldest scientific institution in world history. And it had many outstanding clerics in it in the beginning. Sir Isaac Newton was a profound student of religion who credits his insights about God for his discovery of the law of gravity. Oh well, moving on. John Ray, father of English botany. John Wesley was at the cusp of major scientific breakthroughs. Gregor Mendel, abbot of St. Thomas's Abbey in Brno, Moravia, became the father of modern genetics from experiments, with peanuts in his monastery. And may I say that in monasteries, they have gardens. And the name of the wall that goes around the gardens is called the garth. Albert Einstein. I invite every speaker who will enlighten us in this endowment series in honor of Dr. Perry to read the book entitled Einstein on Peace. 714 pages, documented to the hilt, about Einstein on peacemaking and peacekeeping. William Sloane Coffin Jr., Martin Luther King Jr., Johannes K. Gandhi, Frank Laubach, many others, politicians such as John Stuart Mill. We're talking ministers, scientists who have made science and ministry. Sir Robert Boyle recognized that science and ministry belong together like two hands clasped in prayer. Sir Robert wrote, quote, "It is highly dishonorable for a reasonable soul to live in so divinely built a mansion as the body she resides in, altogether unacquainted with the exquisite structure of it." And so, my wife Cherry and I have endowed this annual lecture series to honor Thomas A. Perry, esteemed professor of Central Methodist University. Dr. Thomas Amherst Perry, 1912 to 2002, was for 20 years chairman of the Department of English and Languages at Central Methodist College. He was also chair of the honors program He sponsored Scribblers and Scrawlers, a club for aspiring creative writers, hosting and entertaining them monthly in his home. He was a visiting professor at Northeast Missouri State University in Kirksville, now Truman State University, at the University of Missouri in Columbia, and the Smith-Smunt Exchange Professorship at the Universidad de Autónoma del Estado de Mexico at Toluca, near Mexico City. He later served as professor of literature and languages at East Texas State University, now Texas A&M University, in Commerce, Texas. He was recognized nationally and internationally as a published Shakespeare scholar. He was the first Fulbright lecturer to the University of Bucharest in Romania. He was similarly recognized as an authority on Romanian literature and Romanian-American literary relationships. In 1984, he received the Distinguished Alumnus Award from his alma mater, Park College, Parkville, Missouri. A variety of publishers printed poems that he authored. His From These Roots and other poems you have a copy of in your chairs. And that book continues to be available. A poem titled The Message from Voyager, from his book Dark Side of the Moon, won the Editor's Choice Award, National Library of Poetry, in 1994. Dr. Perry was listed in the Directory of American Scholars and in Who's Who in America. Since 1992, Dr. and Mrs. Perry have been honored with an annual award in their name to Central Methodist University student committed to intercultural relations. His father, Thomas C. Perry, was a minister and later missionary in Puerto Rico, where our Dr. Perry spent his boyhood. In Fayette, he was a member of the Round Table Club, the Fayette Library Board, the Lynn Memorial United Methodist Church. For 64 years, he was married to his beloved Lord. They were parents of 4 beloved children, a daughter, Laurie, and 3 sons, Tad, Tim, and Chuck. His 3 older children are all graduates of Central and followed in his footsteps by pursuing careers in education. College professor, librarian, and college administrator. And Tad serves as a Central trustee. All 8 of his grandchildren are college graduates, 4 of them having completed doctoral degrees. So quite a clan honors us tonight with their presence. His students we students treasure countless memories from his 45 years of teaching. We fondly recall the resonance of his speaking voice, that twinkle in his eye, his mastery when reading poetry and Middle English with more fidelity to brogue than Henry Higgins. We exult in memories of all he shared about Shakespeare, and I had him for 2 semesters of Shakespeare. All those times he lectured without notes, a head stocked with mind-stretching details, and all his encouraging comments to scribblers and squallers, writer wannabes. Some of us remember November 8th, 1960, when he and Laura entertained many of us students while watching into the night as dramatic election returns filtered in between Richard Milhouse Nixon and John Fitzgerald Kennedy. In the foreword from these roots, Dr. Perry wrote these words: "From these poems also show an awareness of the challenges today to religious faith and seek to reconcile our religious heritage with those challenges, to assimilate the vistas of science into that faith," end quote. It is our hope that the Perry Lecture Series, like his poetry, will show that awareness and reconcile religious heritage with the vistas of science. I thank you all for your presence here tonight and your sharing of Central Methodist University's interest in the ministry scientist agenda. We are deeply honored by the presence of Dr. Jonathan Lunine. We are immensely grateful to him that it is he who will inaugurate the Dr. Thomas A. Perry Lecture Series. Dr. Lunine.
Thank you, Reverend Lee, and it really is an honor to be the inaugural lecturer in the Thomas Perry Faith and Science series. I want to thank Reverend and Mrs. Lee for establishing this, making it possible, Dr. Perry as well, the president of the university. Although I was unable to spend the time I had hoped I could here prior to my talk, thanks to various airline problems, I did get a brief tour, and it's very impressive. Particularly important, though, is that we must have people speaking to the question of science and faith, and testifying to the fact that science and faith are two harmonious sides of the human spirit, and not two endeavors that are forever in opposition to each other, regardless of what the first president of my university might have said in his two-volume tome some 150 years ago. The situation today, unfortunately, can be characterized, is characterized very well by Francis Collins, the director of the National Institutes of Health, an evangelical Christian and a medical biologist. In his book, The Language of God, Collins writes, "In the 21st century, a battle is raging for the hearts and minds of humanity. Many materialists, noting triumphantly the advances of science in filling the gaps of our understanding of nature, announce that belief in God is an outmoded superstition, and that we would be better off admitting that and moving on. Many believers in God, convinced that the truth they derive from spiritual introspection is of more enduring value than the truth from other sources, see the advances in science and technology as dangerous and untrustworthy. Positions are hardening, voices are becoming more shrill." And I think that's a very accurate depiction of where we are today, and it requires individuals both from the scientific community and the religious community to speak out against these extreme views. Now, my experience has been in giving lectures over a number of years now is that the most effective way to demonstrate the harmony of science and faith is to talk about somebody that one knows very well who exemplifies both of those sides. Those can be famous scientists, such as the ones that Reverend Lee mentioned, but the person we all know the best usually is ourselves. And so in this talk, I'm going to be autobiographical. I recognize the dangers of talking about oneself because scientists especially are not rock stars. My background in astronomy and geology, I study stars and I study rocks, but that doesn't make me a rock star. So, this isn't going to be, it's not going to have the edge that a movie about Freddie Mercury might have, for example. but I hope it's illustrative of the fact that one can journey in one's life through towards science, and not away from faith, but actually toward faith in the context of that development of one's scientific career, that the two can actually go together. So what I'm going to do is the talk's divided into roughly 15-minute intervals. First 15 minutes, I'm going to give you my street creds as a scientist, just so you understand that I really am a practicing scientist. The second part of the talk is going to be my faith journey and my scientific journey, heavily compressed because to put 59 years into 15 minutes is a difficult achievement. And then I want to address the question of how being a believer, having faith, might actually make you a better scientist. And for this, I'm going to turn to an episode in the life story of Georges Lemaître, who was a Belgian priest and cosmologist who was the father of the Big Bang model of the origin of the universe. And if you want to learn more about him, I just have had an article published in Faith Life Journal, which is a Notre Dame online publication, and you can read about him there, and I'm happy to give you that reference. So let's go ahead and start with my science. I am a planetary scientist. I work on studying and understanding the planets in our own solar system and also around other stars. I'm particularly interested in the question of whether life might arise in other environments elsewhere in the cosmos. And from my point of view, the best place to test that is within our own solar system, our own cosmic backyard of 8, or depending on how you count it, 8 or 9 planets, numerous moons, many dozens of moons, and other objects. And one of the things that has been learned from planetary exploration, which is literally sending machines out into the solar system to orbit, to fly by, to land on, to touch these objects, what we've learned is that there are surprising places where life might possibly gain a toehold and survive. And some of those places are shown here. They're called the ocean worlds of the solar system. These are places in the solar system where liquid water oceans either exist today or might have existed in the past. Now, Mars and Venus, those oceans are gone. We have chemical and geologic evidence of them. And the rest of these objects are all beyond the asteroid belt, except for the asteroid Ceres, which is another object that appears to have had plenty of liquid water in the past. These other 9 objects spread among the moons of Jupiter, the moons of Saturn, and objects beyond Neptune. These are places where there is either circumstantial or very, very strong, almost direct evidence for liquid water. And in particular, 3 of these objects, Jupiter's moon Europa, Saturn's moon Enceladus, and Saturn's moon Titan, there are multiple lines of evidence for liquid water oceans, and in the case of Titan, surface liquids of methane and ethane, hydrocarbons, bodies of liquid that are as large as the Caspian Sea on the Earth. So in these ocean worlds, these oceans are underneath the surface of ice. These are bodies that are mixtures of ice and rock. So the ocean is sandwiched between the ice and the rock. And I want to focus for a minute on Enceladus, which is the least well-known of these objects, but the one, ironically, for which we have the best evidence that that ocean could support life, that that ocean is habitable. So for most of my career, in fact, beginning as a graduate student in the early 1980s, I've worked on this mission, the Cassini-Huygens mission, a joint mission between the United States, NASA, European Space Agency, the Italian Space Agency, and other space agencies of member states in Europe. The planning for this mission began in the 1980s. The spacecraft were launched in 1997, arrived at Saturn in 2004, and when Cassini finally consumed all of its fuel, it was burned up in Saturn's atmosphere to avoid contaminating some of the moons. This is one of the most ambitious planetary missions ever done. This is a robotic spacecraft that is loaded with 14 instruments and carries this European-built Huygens probe. So Cassini was the famous French scientist who discovered the true nature of Saturn's rings as rings. Huygens was the Dutch scientist who invented the geometric theory of optics. all in the 1600s. And the mission then included this Saturn orbiter, which spent 13 years in orbit around Saturn, touring the moons and rings and atmosphere, and then the Huygens probe that landed on the surface of Titan. So one of the very interesting things that we learned, and I guess we can't really turn the lights off, but maybe the images are clear enough as they are. One thing we learned is that being small doesn't necessarily mean you're inactive. One of the essentially assumptions about the way planetary bodies worked is that the larger they are, the more active they are. They have more volume for the amount of surface area. It's harder for them to get rid of heat if they're bigger. There are more sources of heat, radioactive elements, etc. But it turns out that Enceladus, which is a tiny moon about 300 miles across, is the most active in the Saturn system. And what's happening is that it's being tugged and pulled by the gravitational force of Saturn, an effect called tidal heating. And that tidal heating is forcing material out of the interior of Enceladus, as you see here, in the form of gas and ice pouring out of the south polar region where there are fractures, long fractures, many tens of kilometers long. That material is going into orbit around Saturn, forming a transient ring called the E-ring, which was actually discovered in the 1960s, long before Cassini actually discovered this plume. And then if you look really close, as Cassini gets close to Enceladus periodically, you can see that the plume resolves into individual jets of ice and gas. And some of the closest flybys that Cassini did, as close as about 18 miles from the surface of this tiny moon, 1 billion miles away from us, revealed this very intricate network of fractures that, as the tidal effects wax and wane, as Enceladus moves in its orbit, those fractures open and close, and material comes out. Well, Cassini was equipped with instruments that can measure the composition of gases and grains. And although they were not intended to study this plume, because we didn't know the plume existed, they were put to that use. And so after the plume was discovered by Cassini, there was a study done to determine if it would be safe to fly Cassini through the plume itself. It was determined it was, and Cassini made 12 traverses of the plume at altitudes as low as 50 kilometers. And what it found was that the grains of ice are salty, up to 2% salt, which is about half the salinity of the Earth's oceans. That means that those grains were originally liquid inside of Enceladus, because to dissolve that much salt requires a liquid. As they come out, they're then flash frozen. Embedded within those ice grains, and also as separate grains, were organic molecules, carbon-containing molecules, as well as tiny grains of silica, SiO2, which are an indicator that the water inside of Enceladus is in contact with rock and is leaching silica from the minerals and then shooting it out into space along with the main plume. So if silica is being emitted and there is reaction of rock with the liquid water, a prediction that was made upon that discovery was that there should be hydrogen coming out as well, because part of the reaction of liquid water with rock, as one learns from studying the ocean floor of the Earth, is that one makes hydrogen, which is a fuel source for microorganisms. And Cassini then, on its last traverse of the plume of Enceladus, discovered molecular hydrogen. So all the ingredients for life are present, and the picture we have of Enceladus is a moon with an ice crust, a liquid water ocean, and rock underneath. And the only question that Cassini couldn't answer is whether there's life living inside that ocean. That will require a future mission that I, among others, are trying to push for. So other places, Titan. Titan is a giant moon of Saturn. It's larger than the planet Mercury. It's covered with a dense atmosphere of nitrogen. The air at the surface is 4 times denser than the air in this room. Instead of water being present in the atmosphere, though, because Titan's so far from the sun and so cold, methane is present and acts as the meteorological liquid, forming clouds, rain, and as Cassini discovered for us, seas of liquid methane. So this is a part of a sea on Titan. These areas of dry land, this is a radar image that penetrates through the haze. You can see some river canyons in here as well. All of this is carved by methane. And the Cassini radar was actually used, although we didn't intend it initially to do this, it could be used as a probe of the depth and composition of these seas, and they turn out to be almost pure methane. At the surface, this is an image from that probe that landed. These pebbles, which are either icy or organic, are quite rounded, and that strongly suggests that they've been rolled and tumbled in a liquid. This is a riverbed, essentially, but a riverbed thanks to methane, not to water. So here's an exotic world where the processes that we associate with terrestrial weather are occurring, but they're occurring with exotic materials, methane instead of water, and the geology is water ice instead of rock. And then finally, Europa, the moon of Jupiter, which is about the size of the Earth's moon. 10 years before Cassini arrived at Saturn, actually 15 years before, another spacecraft, Galileo, was in orbit around Jupiter and measured fluctuations in Jupiter's magnetic field every time it passed close by this moon, which has a very icy surface that looks rather youthful. There are no impact craters on this part of Europa. There are only a few in total. But underneath was evidently something that was affecting the magnetic field of Jupiter, and that something had to be an electrical conductor. And so the best candidate for that, because there's no evidence for a metal core, is a salty water ocean. And if this inference is correct, then this ocean has about twice the volume of the Earth's ocean, just based on the size of Europa. Now, we don't know if there are organic molecules present. We don't know if there is hydrothermal activity, reaction of the water with the rock. And so a mission I'm involved in that is in the construction phase that will launch in about 2023 is called Europa Clipper, and it will make many of the same measurements at Europa that Cassini made at Enceladus. So we'll learn whether the European ocean might in fact be habitable. Now, I work on other things. Giant planets fascinate me, and together with a number of other scientists in 2001, we proposed a mission to focus on Jupiter called Juno. That mission was launched in 2011 and has been orbiting now for 3 years. It's taken remarkable measurements and remarkable images. This is the North Pole of Jupiter. And those of you who are used to seeing Jupiter as the striped planet will certainly be surprised that it has this very different appearance in the polar regions. Very organized, very intricate, almost looks like a Van Gogh painting or sort of a version of his Starry Night. And it illustrates how processes that should be random, perhaps, in various bodies in our universe produce very organized and beautiful structures, part of the beauty of the heavens that our Creator has made for us to study and admire. And finally, very briefly, I work on the successor to the Hubble Space Telescope called the James Webb Space Telescope. This is a giant telescope. This is about 24 feet across. This mirror, this shield to block the heat of the sun from the telescope is about the size of a tennis court. And the idea of having something that large and protected from the sun is to allow it to be able to see heat radiation, infrared light, be able to probe much deeper to the edge of our universe than Hubble could, and also to be able to measure the composition of atmospheres of planets around other stars. So I feel very blessed and very privileged to be able to work on all these things. It was a dream of mine since I was a kid, and that's where I want to move into the autobiographical part of my life, of this talk, I should say. When I was born in New York City, and we lived not too far from what is now called the Rose Center, but used to be called the Hayden Planetarium. Hayden Planetarium was a kind of a temple of science. This is an old postcard from the 50s. I grew up in the 1960s. But you would go into this planetarium, and there would be an atrium. There would be classical music. You'd see this sort of rotunda. There would be names of famous scientists and philosophers as well. And you would get this almost religious feeling going into it. And then moving into the exhibit hall with beautiful paintings by Chesley Bonestell of celestial objects, and finally into the domed planetarium itself, where a priest astronomer, effectively, would be standing at a great podium with dials and switches and would lead you on a voyage through the universe, literally. And for a little kid, this was really impressive, and it made me want to become an astronomer. Today, unfortunately, all of these presentations are pre-recorded and run by a computer, so the priest astronomer is now gone. I think that takes away some of the atmosphere of the whole thing. But nonetheless, these are great teaching tools. So I was really hooked on astronomy. And about, I would say when I was 13 years old, a book came out authored by a Cornell professor named Carl Sagan, who at the time was not famous. This was years before his Cosmos series. The book was called The Cosmic Connection, an Extraterrestrial Perspective. I read about it in an astronomy magazine. I ordered it. It did not come the next day by Amazon Express. Okay? No such thing at the time. It took several weeks. When I got the book, I read it, and I was so fascinated with this vision of humankind, not only trying to understand the cosmos, but connecting with the cosmos, being a part of the cosmos, that I spent a lot of time reading excerpts out loud in our apartment in New York City, to the irritation of my sister at least, and maybe my mother, who suggested that if I was so fascinated, I should actually write to Professor Sagan, which shocked me because I thought, you know, he would never write back, this big Cornell professor. My mother insisted, as mothers do, and so I did write to him, and I got back a letter, which is shown in the background, April 18th, 1974, telling me how to become an astronomer, essentially. And also enclosed were some reprints from a recent Mars mission, Mariner 9. Well, this was, of course, incredibly thrilling to me, and it, as with many young people, as it turns out, including some of my colleagues and Neil deGrasse Tyson, who you may know from the Cosmos series, were all influenced by Carl writing back to them, or in the case of Neil deGrasse Tyson, actually inviting him to Cornell. So lesson number one for anyone who's a professor here is when someone writes, a student, high school student, whatever, please do write back to them because it can be really inspiring. So this launched me on my scientific career, but there's another side of my life. The other side of my life was a connection to God. Now, my family was Jewish. I was born into a Jewish family. My mother's side was very Reformed Jewish. They were Reformed Jews. My maternal grandfather, who died 2 years before I was born, apparently regarded religion as the root of all of humanity's evils. So you might say he wasn't a very devout person. But on my father's side, they were conservative Jews, and they did practice. And so sometime when I was 9 or 10 years old, my parents decided that they ought to join a synagogue and give me a little bit of a religious education. And so they joined Central Synagogue in New York City, the oldest continuously operating Reformed synagogue probably in the United States, nearly burned down 10 years ago, but was rescued by a hair's breadth. Beautiful building. I went to religious school there for 2 years. I was never bar mitzvahed or confirmed. In Reformed Judaism, they confirm rather than bar mitzvah. But my family ran into serious financial trouble, and I'll get to that in a minute. This was not the only part of my religious education. We had, as well at home, a family Bible, which, because junior high school was not all that challenging to me, I spent a lot of time reading. It was not a Hebrew Bible, it was the King James Bible, which my father and mother had bought, I think, before I was born. Luckily, I hung on to this. I still have this Bible. I had it rebound a few years ago. And I remember not only enjoying the beautiful colored plates, which were reproductions of paintings by Renaissance artists of key episodes in both the Old and New Testaments. I read in the Old and New Testaments, and I found it all very confusing. It was just hard to understand, but there was something about it that really pulled me in. And it was good to have that when my father, who lost his business and turned out to be an alcoholic, he died of alcoholism and a pill abuser, basically brought our family into a very dark time around the time I was 13 or 14. I have to say that for those of you who have had parents like that, you know how difficult a situation it is, because every day you just wonder what is going to happen next. During this time, when I was about 13 or 14, I had a dream in which I was in a church and there was organ music. And the initial part of the dream, I felt some sense of darkness or dread. And then I felt a sense of light and love and joy. And as I felt that very strongly, I turned around behind, because I felt someone was there. And there was someone there. And it was Jesus Christ who was there. And he carries me out of the church, and then I wake up. Now, we all have dreams. Some dreams are more vivid than others, but sometimes we have dreams that we think are really more than just dreams. And that, I think, was much more than a dream, because it was so vivid and cut to the very core of my person. So what did I do as a teenager? I did nothing. I did nothing. I told my mother about the dream. Her response was, "What more encouragement do you need?" Because she was thinking of actually becoming a Christian. She did informally convert many years later. But the way she said it unintentionally shut me down. And so there I was. I went to college. I majored in astronomy. I went to graduate school at Caltech. I majored in geological and planetary science. I went to synagogue maybe 4 times during that period. I think I became a nominal deist. I would say, well, some greater force probably made the cosmos, but we can't know what it is. And I really put everything behind me, including that dream. Then I got my PhD. I moved to Tucson, Arizona, where I taught at the University of Arizona for 26 years. The second year I was there, I met my wife-to-be, Cynthia, who came from a rural family in southwestern New Mexico. Her father was a deacon at the local Church of Christ. It wasn't the United Church of Christ, it was independent. And she had thrown over that very conservative Christianity in her college years. But she was looking at a Methodist church in Tucson, St. Francis in the Foothills, when I met her, and we both ended up joining. This is a very liberal Methodist church. I'm not going to apologize for that, I'm just telling you that as a fact. It was a good thing for me because it meant that I could go into the church doors without having to make a commitment. And inside those church doors was Reverend David Wilkinson, who just retired about 6 years ago, who is a brilliant man, a brilliant sermonist, homilist, extremely well read in the fathers of the church, all the way up through Teilhard de Chardin, who he read avidly, and who had the fire of love and faith in him that he was able to transmit along with this very deep knowledge. So for about 15 years, we would go pretty regularly to St. Francis. We had our son baptized there, but I was not baptized there. But I absorbed these homilies, and they had an effect on me. But I didn't know it at the time. What also had an effect on me was that teaching at the University of Arizona in Tucson, I began to be better acquainted with a group of astronomers there who were all Jesuit priests, who were part of the Vatican Observatory, whose headquarters was in Castel Gandolfo near Rome, but had a Western headquarters in Arizona for a reason that I'll explain in a minute. The Vatican Observatory has had a sort of politically a checkered history, but it has represented Vatican support, Roman Catholic Church support for astronomical research since the late 16th century, when the Gregorian reform of the calendar occurred, and one of the key players in that was Christopher Clavius, a Jesuit mathematician who designed this experiment in the Tower of the Winds in the Vatican, where he used a pinhole to track the orbit of the sun day by day over a year and helped to verify the new calendar that we use today. That started the tradition of having mathematicians and astronomers in the church. And despite what happened with Galileo, which is another complicated story and another interesting lecture, that tradition has gone on for centuries. So for example, in the late 19th century, Father Angelo Secchi, another Jesuit, began the process of examining stars by spreading the light from those stars out using a prism or a grating so you could see the individual wavelengths. And because different atoms will absorb light at definite wavelengths of light, like fingerprints, he was able to use this technique to classify the composition, to measure the composition of stars. And he's generally regarded as one of the fathers, if not the father, of stellar spectroscopy. The observatory became officially the Vatican Observatory after the reunification of Italy in the late 19th century. By 1980, it became difficult to use the telescopes in Rome because of light pollution. And so, the director of the Vatican Observatory in the late 1970s, who was a Jesuit priest and had been an associate director and acting director of the astronomy department there, George Coyne, sold the Vatican on the idea of building a telescope in Arizona, raised money primarily from US donors, used a telescope mirror that was a test mirror for a revolutionary new process developed at the University of Arizona to spin cast mirrors and produce a very precise shape. This test mirror is 2 meters or 7 feet across. The largest they've cast so far, 8.4 meters, which is about almost 30 feet across. And this was built and installed in Arizona on a mountaintop, the Vatican Advanced Technology Telescope. So they do frontline research, and they are all Jesuit brothers or fathers. And so what I came to experience in interacting with these astronomers was how harmonious and seamless were their lives of science and faith. They had responsibilities to the church, they had responsibilities to their science, and this was all done in a very seamless way. I eventually stayed with them for some months. I taught they have a summer school in Italy every 2 years where they bring graduate students in for 6 weeks. Some well-known planetary scientists and astronomers have been through that school. Here's an emaciated version of me lecturing in 2005. It was during that 2005 period, which was the start of a sabbatical, an academic sabbatical in Italy, of course with my wife and our son, that I began to feel myself kind of letting go, that there was something that I was holding back that was being, I think, challenged or released by being in contact with these Jesuit brothers and fathers, and it was probably loosened by those 15 years of beautiful sermons by Reverend David Wilkinson. And so when we came back from our sabbatical in 2006, I remember sitting down in our living room alone and suddenly realizing that for 30 years, I had been dancing on the edge of a swimming pool. That was the sort of mental metaphor. And that in my late 40s, it was really time to actually do something. And I realized that what I had put off for many years was accepting Jesus Christ as my Lord and Savior and the Son of God. And so I called up our son's pediatrician, who was Catholic, and a good friend of ours, and I said to him, Bill, would you think I was crazy if I told you I wanted to become a Catholic? He didn't miss a beat. He said, no, of course not. I'm not crazy at all. I'll introduce you to Father Miguel at the local Newman Center, which he did. Bought me a giant book on Catholicism, by a famous Notre Dame professor, which I read cover to cover. And I went through the RCIA process, the adult conversion process. And on Holy Saturday, April 7th, 2007, I was baptized and confirmed in the Catholic Church. Now, just an aside, you might ask, well, why didn't you become a Methodist? And it was not that I had anything against Methodism, but I had, there were three reasons really. One was that the Jesuit astronomers had really made a big impression on me. The second was this very long intellectual tradition, which is held by all Christian denominations, but I felt I could better access as a Catholic. The third was that it was, in terms of the rites and the liturgy, the most Jewish, I thought, of the Christian denominations. And so I didn't have to do as much switching over. I became a Catholic. So anyway, I was very afraid to come out for many years. I mean, here I am, a tenured professor, suddenly converted to Catholicism. It took a number of years before I would give talks about this. Friends helped me to come out on this, in particular Brian Schmizek, who was the dean of the ministry school at the University of Dallas, who arranged for me to talk at a Dallas ministry conference about 7 years ago. But eventually I came to realize that I had to witness to this, and that by witnessing, it didn't affect the quality of my science. And also amazingly to me, my colleagues in the Department of Planetary Science and Astronomy at Arizona, and then at Cornell, accepted this. Now, that isn't going to be everyone's universal experience, but particularly at Cornell, I was surprised at the lack of antipathy that I encountered. We can talk a little bit more about that during the Q&A. So it didn't hurt my science. In some ways, I thought it made me a better scientist because I felt more patient. I could see the light of Christ in other people. And so, whereas I tended to be a very kind of sarcastic and almost negative person through most of my career, I softened. And I think for me that was very important. So one of the things that one of the projects I've been doing is trying to nurture along the Society of Catholic Scientists. About 4 years ago, 3.5 years ago, realizing that students who were Catholic needed a way of having fellowship beyond just their Catholic organizations on campus, which frankly Cornell was pretty thin. I thought it would be good to have a society, and I contacted a colleague of mine, Stephen Barr, professor of physics at Delaware, who is also Catholic. I had read an interview that was done in American Magazine, and I emailed him, and he said, well, I was thinking the same thing, so let's do it. So he had the connections. We worked for about 2 years to make this an official organization of the Roman Catholic Church. We were chartered and started up in 2016. We've had 2 annual conferences. We have a board of 8 great scientists, all of whom are practicing Catholics. And the purpose of this society is shown on this website, but the most important is to witness to the harmony between the vocation of scientists and the life of faith. We're not going out there to try to attack the Richard Dawkins and Christopher Hitchens of the world. We want to demonstrate that harmony by simply being who we are and holding conferences and mentoring students and having discussion sites and so forth. So we are up to our 1,000th member, close to it. In fact, we're trying to figure out what gift we'll give this 1,000th member, all of whom are active scientists or students and also practicing Catholics. So now I want to get to the very last part of my talk, which is to try to address the question of, does being a scientist and a believer make one a better scientist? And I think the answer is yes. I've given you one sort of cursory example of that in my own case. But I want to give you another example of someone who is a truly great scientist and a practicing Catholic, in fact, a Catholic priest. Georges-Henri Lemaître, a Belgian priest and cosmologist who was born at the very end of the 19th century, died in the mid-1960s, and is universally acknowledged as the father of the Big Bang model of the cosmos, the model which has been validated by a number of astronomical observations that about 14 billion years ago, right now 13.8 billion is the number we think is right, everything, space, time, matter, were in a different state that was very compressed, inconceivably small, and from that particular state, everything began. And he was the first to come up with this idea. He published it in 1931, the journal Nature. But he did much more than that. In fact, he nearly became the person that would be recognized as having invented Hubble's law. Now, what is Hubble's law? Okay, I will get to that in a minute. It's a very important relationship in astronomy. So we go back to 1917. Einstein invents the general theory of relativity, a theory of gravity. And he's living in a world where it's not yet understood that the universe is expanding and that these sort of fuzzy, blobby, spiral things that are kind of seen in telescopes are not part of our own Milky Way galaxy, but are distant galaxies unto themselves. The universe that he knew based on the data was a static universe. And so in order to reconcile his theory of general relativity, which says that matter bends space-time and would cause space to collapse if there were no other opposing force, Einstein put into his equation something called the cosmological constant, which was basically a fudge factor, which he didn't like. About 10 years later, a young mathematician physicist who had become a priest 3 years before, Lemaître, who was fresh out of graduate school at MIT, having grown up in Belgium, engaged with the astronomical data, which at that time, a decade after Einstein, had begun to show that galaxies were moving away from each other. That if you looked at a distant galaxy, its light would be slightly shifted to the red, or sometimes greatly shifted to the red compared to a galaxy near you. And that suggests that the galaxy is moving away. Not quite because of the Doppler shift, but as Lemaître himself first realized, he was the first to realize this, because it becomes redder because space itself is expanding. And those galaxies are being carried in this cosmic flow of the expansion of space-time. So Lemaître worked out a solution to the theory of general relativity, which had an expanding universe and had matter in it. Those two things together had not been done before. And he engaged with the astronomical data. So he didn't just do the theory the way that Einstein did. He worked with the data. And what he realized in working with those data was that his model would produce a relationship between the recession velocity of the galaxies, the speed at which they're moving away, and their distance that was in exactly a proportional relationship, the equation of a straight line. A galaxy that was twice as far away would be moving twice as fast, okay? And that relationship today we call Hubble's law, because we all think that Hubble discovered it. But Lemaître published it first from his model, but he published it in a poorly known Belgian journal written in French, which in 1927, French was not the leading language of science. The leading astronomers were in the United States and the United Kingdom, and very few people actually knew about or read this paper. 2 years later, Hubble publishes in the Proceedings of the National Academy of Sciences of the United States, 1929, his data that show this exact same linear relationship, and everyone thinks he was the first to actually come up with it. And so we have Hubble's law, and we have Hubble Space Telescope. In 1930, one of Lemaître's former advisors, Sir Arthur Eddington, a famous astronomer and actually a devout Quaker, thought he had come up with the same solution. had forgotten that Lemaître had shown him a copy of the paper and gave some talks about this. When Lemaître learned that, he wrote to his former advisor and said, you know, I published this first in 1927. Eddington, who was a very humble and honest man, realized that immediately, was mortified. We all do that. We sort of incorporate what someone else has done in our heads and we think that we invented it. It's a psychological phenomenon. So Eddington immediately insisted that he arranged for an English language translation of Lemaître's 1927 paper that establishes what was then called Hubble law. And it would be published in the monthly notices of the Royal Astronomical Society under Eddington's aegis. So Lemaître agreed to that. The paper was published in English in 1931, and the one paragraph that explained and derived this linear relationship among all the other paragraphs that described the general relativity model was missing from the English language version of the paper. That would have given Lemaître equal credit with Hubble. And the question is, why was it not there? For decades, there were all sorts of conspiracy ideas that, you know, it was anti-clericism, or Hubble himself had intervened to have the paragraph removed so that his priority would not be damaged or diminished in some way. None of that turns out to be the case. About 6 years ago, an astronomer rummaging through the archives of the Royal Astronomical Society discovered this cover letter that Lemaître had written to the editor of the monthly notices, in which he says, I send you a translation of my paper. I made this translation, so he was the one who did it, and I didn't find it advisable to reprint what Lemaître calls the provisional discussion of radial velocities, that's the recession velocity, which he says is clearly of no current interest. He says actual, that's a false friend between French and English. Professor Perry could have lectured on that at length, but anyway, what Lemaître meant was of no current interest. And what he was saying was that because the two intervening years between 1927 and 1929 had produced so much more data that Hubble was able to use to definitively establish the relationship. There was no point in Lemaître retranslating and publishing into the 1931 version of his own paper something that used out-of-date and coarser data. His derivation was perfectly correct. It came directly from his model, but he felt that it was really not of current interest to just publish old data. Now, how many scientists, how many astronomers, professors, biologists do you know who would give up the chance to get equal priority on what had become a very important relationship for this reason? This speaks to the deep integrity and humility of Lemaître, who exhibited this throughout the rest of his career in many other ways. And I have to say that the behavior of both Lemaître and Eddington in all of this, both of whom were deeply religious men, I think speaks to the things that come from their deep sense of faith. I can't prove that, but I would assert that. Hubble, by the way, was a great showman. He was in charge of the largest telescope on Earth at the time. He entertained Einstein. He always, you know, he pushed the credit that was given to him to the hilt, but he never understood the expanding universe model. He didn't understand why there were redshifts to the day that he died. Okay, so I want to close now with a few quotes that have inspired me, coming from Lemaître and others. Lemaître has many quotable quotes about science and faith. Here's one of them. He said in an interview in the New York Times in 1933 that there are two ways of arriving at the truth, and he decided to follow them both. One is his faith, the other is his scientific work. And he says, nothing in my working life, nothing I've ever learned in my studies of either religion or science has caused me to change that opinion. I have no conflict to reconcile. Science has not shaken my faith in religion, and religion has never caused me to question the conclusions I reached by scientific methods. And I have to say, we all have to take a dig at Dawkins once in our talks, right? The accomplishments of this man in science are vastly greater than any of the accomplishments that Dawkins has made. And if that kind of measure allows one perhaps to establish priority of opinion in some way, I think that statements like this need to be given much more press and much more publicity than they actually are. Of course, there was no internet at the time, so these things are less well publicized. Equally interesting is that Lemaître had a lot to say about why the cosmos was comprehensible. He believed that God's hand was always hidden in the physics. In fact, in his paper outlining the Big Bang model, in a first draft he actually said that, but then took it out because he realized that Nature would never publish it that way. But he also addressed the question that Einstein posed, which is why is the world comprehensible? Why is the universe something that we can understand? The materialist explanation of why we're self-aware and how our brains work is that these are evolutionarily derived as hunter-gatherers and as animals that have to survive using our brains. But why should that set of tools, why should that toolkit allow us to understand the entire cosmos? And Einstein said that that's an eternal mystery. Lemaître didn't find it a mystery. He said in the same year that Einstein said that the comprehensibility is an eternal mystery, Lemaître said that both the scientist believer and the scientist non-believer attempted to coding the palimpsest of nature, the remnant, the hints that nature leaves behind of how things happen. The believer perhaps has an advantage of knowing that the riddle possesses a solution, that its degree of difficulty is presumably measurable with the present and future capacities of humanity. And what he meant was that God wants humans to discover and understand and appreciate and love this universe that he has created. And that's why we can understand it. And I think that's a much better explanation than the materialist explanation, which is that we can accidentally understand it. So I try to live both sides of my life as harmoniously as these individuals who you can see are kind of my heroes at some level, the Vatican astronomers, Lemaître, both the scientific side and the spiritual side of myself as best I can. It doesn't always work. Sometimes I find myself wrestling, as Jacob did with the angel. It's not a lack of faith in God, it's a how shall I put it? It's a disappointment in myself that sometimes I can't harmoniously see and feel both sides coming together, that the work I do scientifically inspires me to a deeper love of what the Creator has done for us. Sometimes I do, sometimes I don't. But there are always the people who've come before us, the scientist, how did you put it? The scientist, what did Reverend Lay call it? You call them scientist ministers, thank you. The scientist ministers of centuries past who inspire us to recognize that the statement that science and faith are incompatible with each other is simply false. And so I'll close with three of those scientist ministers. I'll start with St. Clement, who was the earliest church father, who wrote in his letter to the Corinthians in 96 AD, the foundational statement for how we do science, the immutability of the physical laws of the cosmos. The sun and the moon, with the companies of the stars, roll on in harmony according to his command. The unsearchable places of abysses and the indescribable arrangements of the lower world are constrained by the same laws. So everywhere in the cosmos, the things we can touch and the things we can't touch obey the same physical laws. That's essential to being able to do science. The ocean impassable to man and the worlds beyond it are regulated by the same enactments of the Lord. 1400 years later, Nicolaus Copernicus, who Reverend Lay already cited, wrote that to know the mighty works of God, to comprehend his wisdom and majesty and power, to appreciate in degree the wonderful working of his laws, surely all this must be a pleasing and acceptable mode of worship to the Most High, to whom ignorance cannot be more grateful than knowledge. And finally, I'll close with what Georges Lemaître said when he was accepting the Franqui Prize in the 1930s. He was nominated by Albert Einstein. At the time, it was the second most lucrative prize after the Nobel Prize. And he wrote, "Science is beautiful. It deserves to be loved for itself as it is a reflection of God's creative thought." So for any of you young people out there who are questioning whether you can hold on to your faith and do science and have a career of science at the same time, and if you don't believe me and my life story, believe these individuals. Thank you. So I've been told I can take questions until I'm pulled by a cane off the stage. So, go ahead, I'm fair game. Yes?
Here in Missouri, faith is frequently described as a faith of biblical literalism.
Mm-hmm.
And for people who, for them the Bible has become God, have an extraordinarily difficult time with science.
Yeah.
So can you speak to the nature of faith, or your faith, that is beyond biblical literalism?
Okay, I'll try to do it briefly. So I'm not a biblical literalist. Neither, by the way, was Thomas Aquinas or St. Augustine or Lemaître for that matter. I believe that the Bible is the inspired word of God, but the instrument through which the message was delivered were human beings of the time in which they were written. And so they cannot have had all the knowledge that we have today. In fact, a Bible in which, Lemaître has said this, in which general relativity is present. He said St. Paul didn't need to know general relativity because it was irrelevant to the question of the salvation of people. To have all of that in there would be incoherent. And 1,000 years from now, our understanding of the universe is going to be totally different again. So what we talk about today is going to be out of date. But what is not out of date is the central message of the Bible, which is that human beings need to be saved, and we're saved by Jesus Christ, the Son of God. And the whole Bible is the salvation history, the history of human beings coming into knowledge of God and turning away from God, and then finally being saved. That message doesn't require that what's described in there in terms of nature or particular events or so forth be literal facts in the sense that we would consider a history book or a science textbook to be. So that's my view. I think it makes a lot of sense. I think it's essential, frankly, as a scientist to understand the Bible in that way. And as I said, I have, I think, the backing of a lot of great human beings over time who were persons of faith as well. And I think it also, to be honest, makes the Bible a much deeper and richer treasure of insights into God, of the revelation of God, than to try to take it absolutely literally. Yes?
I grew up about 5 miles from New York City, so I spent many happy hours in the Haiti Planetary.
Oh, you did? Okay, good.
A wonderful place.
Yeah.
But I wanted to ask you, you had said that your mother had a copy of the King James Version, I believe?
It was our family Bible, as far as I could tell, yeah.
That's interesting to me, growing up in a Jewish family.
Yes.
Where did her interest in that she had her own copy of the New Testament?
I never asked her where it came from. It was our family Bible, period. Now, I have actually, so I did look this up some time ago, and apparently a lot of American Jewish families have a King James Bible because it's just so famous as a work of English literature, essentially. And that may be why they had it. Now, bear in mind as well, my mother, we had a Christmas tree, okay, as well as Hanukkah candles. My mother was a Rockette at Radio City Music Hall, so she had retired in order to get married and have myself and my sister. She went back after my father died in order to make money, but you know, the Christmas show at the Music Hall was a wonderful spectacle. So I think we were a typical product of the sort of mixed culture of America. But what's important in in absorbing that is that as part of that mixed culture, there isn't really Jesus Christ in Christmas, right? I mean, a Christmas in New York City is a Christmas tree and lights and Santa Claus and music. So that wasn't what pulled me finally in the direction that I went. It was really reading, I think, that King James Bible, and then opening up during this very difficult time in our family to the point where Jesus Christ could come into my life. And then shutting the door for 35 years, which is pretty interesting in retrospect. Yes?
As a chemist and as a believer, I don't find any conflict there.
Mm-hmm.
But there are some things that create some tension from time to time.
Yeah.
And I've learned to kind of embrace that tension. How do you embrace those things that do cause a little bit of tension between your science and your faith?
So initially, I would just avoid them because that was the easiest thing to do. I think probably, so one of the questions is, where are those tensions? What are the tensions? Are they concerns that a direction you're going in your research might militate against evidence of God as the creator? And I think there is nothing in science that does that, because by definition, science deals with trying to understand the physical and chemical nature of the cosmos itself. By definition, one cannot then understand an omnipotent being that transcends that cosmos. It's simply out of the realm of science. But I think where it becomes difficult is in having discussions with other colleagues about the spiritual implications of science, the wonders of the self-organization of nature, the incredible structures that are present, from the structures in the chemical elements to the structures in Jupiter and galaxies. You very often hear people kind of articulate this Carl Sagan-esque thing that, this all shows how wonderful the universe is, but without connecting to why the universe is wonderful. And not being able, I try not to push that on my colleagues because I don't want to proselytize. I think it's important to maintain with my colleagues the relationship that respects their views and my views. If they attack something that has to do with religion or Christianity, I push back on that. But I have to say, I'm sorry this is sort of a rambling stream of consciousness answer, that I have been very surprised at the extent to which there is not a tension, particularly with my colleagues at Cornell. And Cornell, despite its reputation, we have something called the Chesterton House, which is a Christian living community for students, which brings great speakers onto campus. We started a Thomistic Institute. We've been able to draw 90 or 100 students to those evening lectures. And so, Andrew Dixon White might be rolling over in his grave, who knows? But, things are not as hopeless at Cornell, let's say, as one might otherwise think, except in evolutionary biology. Believers, a graduate student I know who was a member of my parish said that he would catch hell from his fellow graduate students for being a believer. It's much tougher in evolutionary biology. Yes?
I think sometimes as people of faith, we think of scientists as it being difficult to convince people of faith in science to consider faith in God. I'm a pastor at home. I'm a pastor.
Pastor.
And I think sometimes it's actually harder to convince people of faith to be interested in science. Do you have any advice for how, as ministers, as people of God, we might inspire interest and pursuit of science?
So I think, so there are two sides to this. So you're talking about people who don't evince an interest in science, but maybe are not doing so because they think it would be incompatible with their faith. And so I think the best way to deal with that is to bring in speakers who can talk about their own experiences and give examples of how science and faith can actually interact to bring the other alive, to bring them alive. There are books. I mean, Francis Collins' book, for example, which is autobiographical, is a wonderful exposition of that harmony, and is very readable, and I would strongly recommend it, certainly, among such testimonials. So a combination of those books and having speakers. We lose people all the time. I mean, I gave a talk at my parish, and afterwards a young high school student came up to me, and she said that she really appreciated my talk because she wanted to go into science, but her boyfriend told her that she couldn't go into science and believe in God. And of course, she believed her boyfriend. So in the end, I thought, well, hopefully this has disabused you of that notion. She majored in history. History is great. It's a great thing to major in, but she did decide not to do science. I gave another talk at a Knights of Columbus event, and a woman came up to me and said, how do I deal with my son who said that he can no longer believe because he's taking a science class and everything they talk about in there shows that what's in the Bible is wrong. And so, it is just such an uphill battle, and the fundamental reason it's an uphill battle, I think, is because most people of faith just don't have the time to get a deep enough education in their faith that they can actually understand the compatibility, the deep compatibility rather than the surface incompatibility. It really requires education. So Francis Collins' book, Kenneth Miller's book, Finding Darwin's God, those are all good tools. Yeah. Yes?
Last week in the NCR, a Templeton Prize was announced, and this was a physicist from Dartmouth University, and as you know, the Templeton Prize is one of the great prizes
Yeah.
in the country. And you have a spiritual view of life and with your activities and when you are given that prize. And this physicist from Dartmouth, first South American to win the prize, by the way, a Brazilian would win it. But he claimed after the same article I read in the NCR, it said that he was agnostic. And I wonder if you care to comment on that.
So who was it who won?
Well, I was going to pronounce his name, Rolando Geisler.
Geisler, okay, I don't know him. Well, I can't speak for him. I don't know who he is. I can tell you that, how shall I answer this question? There are plenty of scientists who are believers and are not agnostic and who have gone on to do great science. Actually, I can maybe use that question to address something else, which is the claim by atheists that yes, many scientists are believers, but the best scientists are not believers. That if you look at the percentage of scientists who are believers, you look at the National Academy of Science, of which I'm a member, it's much lower. I think those numbers are fraudulent. I think they're actually based on sampling certain people that they know. I think they're based on many scientists not wanting to actually put their faith out on their sleeves and actually, show the public what they believe because they don't want to have to deal with their colleagues. I did that for several years. I think there's a lot of that. There's a very accomplished physicist at Cornell who I tried to get into the Society of Catholic Scientists, and is a devout Catholic, and he's a really devout Catholic. And he didn't want to join because he didn't want to put his interior life, his faith life, out into the public arena. It's unfortunate as part of this problem that we have. So I'm sorry I didn't answer your question, but at least I was able to answer a question that you didn't ask. Yes.
I've always found it interesting that medical professionals are, it appears, not no data, no scientific, just it appears that many, a large percentage of my medical professional friends are people of faith.
Yes.
They are scientists. They have understanding of things that, but that percentage of believers among the medical scientists seems to be greater than the percentage of believers among the physical scientists.
And Francis Collins has a very beautiful explanation of that. So he grew up in a Protestant household. I forget what the denomination was. He became an atheist in his undergraduate and graduate career. Before he got his PhD in biochemistry, he decided he would switch tracks and become a medical doctor. And while he was a medical student, he began to experience through the way that his patients who had faith handled their suffering. He began to experience the light of Christ. He didn't know it was Christ. Initially, he converted, he believed in God, and then later he had an experience that made him accept Christ as a Savior. But there's a beautiful story in there about a woman who has terrible angina and is basically terminal, and they can't control the pain. And at one point, she turns to him in his many visits to her, and she says to him, "So what do you believe, doctor?" And he didn't have an answer for her. And he realized after that question that what he actually believed was that he believed in God. But it took the statement of this woman who was dying and was in horrible pain to crack that open for him. And I think doctors have experiences daily that the rest of us just don't have. My friend, the pediatrician, who became my godfather, when we were sitting in the Holy Saturday Mass before the baptism, at one point turned to me and he was crying. And he said to me, "I can't stop thinking about all the children I hurt over the years." He hurt in order to cure them because pediatric medicine is painful. And I mean, he felt it from the heart. And he saved so many. He saved our son. How many of us have to deal with that in our lives? Doctors do. Yes.
Curious to hear your perspective. So you touched on this earlier, kind of the notion of wearing your faith on your sleeve a little bit.
Yeah.
Do you feel like in your field specifically that is maybe closing doors for you, or maybe you feel like it's open just as many as it has closed? I don't know.
So one of the things I feel guilty and slightly fraudulent about is that all of this happened after I got tenure. And I keep thinking, what would have happened? I mean, I got tenure, I have to say I got tenure very early. I became an assistant professor in 1986, and I had tenure by 1990, I think. So this was years before all of this happened. And so two things come to mind. One is maybe I subconsciously shut myself down until I felt assured enough that I could let go. I don't think my subconscious is that smart, but who knows. And the other is, what about all those students or assistant professors who are vulnerable? And I can't answer that. I mean, everybody has to choose their own way in this. There are scientists who early in their careers were very public about their faith. I'm not talking about the Jesuits, because that's part of their life, but others who are in the secular world, sometimes it didn't turn out so well for them. And even though it's illegal to judge a tenure case on the basis of religious belief, there's a lot of discussion that goes on in those faculty meetings that you never want to hear outside of the room. So it's a problem. And all I do is I try to encourage people to hold on to their faith, to realize that they don't have to be public, they don't have to preach in order to be faithful to God, and maybe there are times when they want to keep it a little bit lower key. But in the case of this guy at Cornell, he had gotten tenure a long, long time ago. I mean, in his case, I just thought, what is your problem? But I didn't actually say that. So we'll eventually get him in the society, yes.
So maybe you're familiar with the book, Darwin's Black Box.
I am, but I haven't read it. I
Well,
have to admit, so, yeah.
there's an example in the book that goes something like this: the amazing complexity of the human retina is evidence that God exists, because there's no evolutionary way we could have had the retina absent God's existence. So you're a cosmologist.
Well, I'm actually a planetary scientist.
Okay.
When I talk about Lemaître, I'm a pretend cosmologist.
In your field, have you seen something out through the telescope that you say to yourself, that's it for me? There's no other explanation of the existence of God from what I see.
So everything I see is evidence for the existence of God. because God has created a universe that is beautiful and livable in, but he's done it through the physical laws that he himself created. He doesn't have to do it as a kind of a cosmic tinkerer, I suppose you could say. He's done it through those physical laws. That's my view. There isn't any phenomenon that I've seen in particular that, I mean, there are plenty of phenomena you can't explain, but that's a God of the gaps argument, right? You can't explain it today. 10 years from now, you can. If you invoke God because you can't explain it today, but you can explain it 10 years from now with physical laws, you've done a disservice to your faith in many ways. So as far as these arguments about irreducible complexity, and I know there are biologists who adhere to this view that's a kind of an intelligent design view, I would just urge you to read Francis Collins's book and also Kenneth Miller's book. So Kenneth Miller's a Catholic, he's a biologist. He is, with his former grad student, they're the authors of, I think it's the third best-selling biology textbook ever published, and it's gone through multiple editions. Miller and I forget the other person. But anyway, well, the textbook is biology, but what you want to read is Kenneth Miller's popular book. There are two of them. One is called Finding Darwin's God, and the second one, which is a sequel to that, is called, quote unquote, Only a Theory, which is a sort of a sardonic comment in the title, because he argues that evolution is more than just a theory. But he's a believer, and he gives these very, very clear explanations of why things that have been ascribed to irreducible complexity really can arise through evolution, which is part of the physical mechanisms that God set into play 13.8 billion years ago, in my opinion. Yeah, go ahead.
Yeah, follow-up.
This is a follow-up,
Sorry.
okay. That's all right. We'll get the White House intern to pull the microphone.
I'm sorry. Do you believe that you chose Catholicism over Methodism in large part because the Catholics had better telescopes?
Yeah, so I will answer that with a story. A few years after I converted, my wife's son and I were back in Italy. In fact, for a while we thought we would just move out of the United States and live there. It turned out to be harder than we could ever imagine. We came back. But we were in Italy, I think it was in summer, and we were having dinner with Guy Consolmagno, who's the current director of the Vatican Observatory. He's the one you saw in the picture with Pope Francis. And I've known him since he was a postdoc and I was a grad student. He was at MIT, I was at Arizona, but then he came to Arizona as a postdoc, long before he became a Jesuit. And he also was a very irreverent, slightly irritating personality before he converted. Anyway, after this dinner, which again was a few years after I converted, we walked out of the restaurant, and Guy sort of hung back from my wife and son. And he stopped me and he said, "Can I ask you a question?" And I said, "Sure." And he said, "Please tell me you didn't convert because of us, did you?" And I lied to him. I said, no, it wasn't you at all. But it was their inspiration that, was part of, it was a kind of a reassuring balm that somebody could continue in a career in science and also admit to their own deep beliefs in God. Now, years later, I admitted to Guy that I had lied, and I apologize for that. People often ask him if, they can confess to him, and he's a brother, not a father, so he says, "Well, I can hear your confession, but I can't absolve you." So, but anyway, the answer to your question is yes, it's partly their influence. Not Christianity, but Catholicism versus the Methodism. That's not a dig at Methodism at all. My wife has remained in the Methodist Church. She's a trustee of St. Paul's United Methodist Church in Ithaca. Sometimes if I'll go to Mass on Saturday night so I can go listen to her sing on Sunday morning. I think we have a very harmonious relationship. What's important is not the denomination you belong to. What's important is accepting who Jesus Christ is.